All right, now I finally got this figured out. Um, Watch this thing right here. I made this little pointer here so it follows that graph. See, that's what I was expecting people to say. In my first class, nobody said anything. Everybody just sat there, just stone-faced. And it is pretty cool, though, isn't it?
Yeah, it changes the points up on the
Yeah, look up here. The cool thing is it shows you exactly. Watch what it shows you. See, at point A, that's where I'm at right here. Now, I took the B and the C off of here just so you didn't have to see it, but that's what the B and C represent. The B represents this point right here because it's like 41 degrees 0. I don't think that's us, right? When are we? 28? Okay, good. So this B represents this point down here, but I took the B off of there just because it got in the way. And I took the C off of there. What does the C represent? That point right there. Now the A is both of them, okay? It's the degree. So the first one is the degree, and the second one is the value for it. Now, I'll tell you what. Let me scooch this up the other way. A little bit bigger. And we'll try to get them to lock on, all right? So like at 0 degrees, watch. If I go to 0 degrees, look at it. 0 degrees, the value of the sine at 0 degrees is 0. That's what it's telling you right there, all right? If I go to 30 degrees, yeah, locked in right there. Look, at 30 degrees, what's the value of it on this ordered pair? It's a half. So what it's doing, it's giving you an ordered pair. What's the first thing in the ordered pair? The angle. What's the second thing? It's the function of what you're doing. It's the sine of the angle. Does that make sense? Now, it's the sine because I programmed the sine into it. All right, I also did one with the cosine. We'll see that in a second. Watch, if I go to 60 degrees, sometimes it doesn't just lock right up. You're hitting my thing by moving all around. All right, watch. Let's see. Maybe if I go to... okay, it locks in if I touch it right there. Yeah. See, 60, and what did we say? 0.87. See, that's exactly where 0.87 was. We kind of guessed, didn't we, when we drew our little dots? But this tells you exactly where it is. So it's kind of handy, all right? You get the idea with that. I'm going to scooch this out a little bit so you can see. Keep forgetting to hit the shift key. And this keeps just going forever, doesn't it? All right? At some other point, we'll restrict it so it doesn't go on forever. Right now, it just basically just goes on forever. Because why? Because you can go around a circle as many times as you want, can't you? That's what it represents. Either direction, exactly right. And the other direction is the negative direction, right? That's why you have the negative angles. Do you see it? It's just a nice, smooth curve. We call that thing a sinusoid. It's kind of weird. Sinusoid. All right? Not just because it's a sine, but we also call the cosine a sinusoid as well. So in general, yeah, this style of graph, right, it's not a parabola, it's not a whatever, right, hyperbola, it's called a sinusoid, okay? So these trig functions, when you graph a trig function, the general word for it is a sinusoid, okay? Let's see what else I want to say about this. Let's talk about this. Oops. Let's make this a little bit bigger. And I want you to see something. Now we know how much one circle is, how many degrees one circle is, but let's relate it to this. Because this is basically a circle just stretched out, isn't it?
Yep.
All right, that's really what it is. What I want to do is I want to find, tell you the truth, let's get rid of these things. Come on. There we go. And let's get rid of that and that, just to get them out of the way. It was kind of cool, though, wasn't it? That thing right there.
It's amazing.
Watch this. Let's do this. Am I on a marker yet? No, right there. Let's say this is our beginning point. There really is no beginning to this, is there? Right? It just keeps on going infinity in the negative direction and infinity to the positive direction. But let's just say this is our beginning right here. Where does it start the repetition all over again? It's just a cycle, isn't it? It just keeps on going and going and going. At 360, that's right. From a lot of people, for some reason, they think that would be one complete cycle, but it's not.
Because
okay?
It doesn't go under
That's
yet.
right, it doesn't go under yet. You got to include everything. So from there to there is one complete cycle. It's one complete turn around the circle, basically, is what's going on, isn't it? Well, in algebra or trig, we call it the period of the function, all right? What's the period? The period is measured in degrees, or radians if we're doing something in radians, okay? So if it would be 2 pi radians if it was in radians, right? But we're doing stuff just in degrees just to make it a little easier for you. So the period would be what? 360 degrees. Now, there are equations, and we're not going to do today, we're going to do eventually, that the period may not be 360 on these graphs, okay? Remember what this one is. This is just basic regular y equals the sine of theta, okay? We're going to be doing stuff like this. I'm not going to talk about this too much right now, but we're going to eventually be doing stuff like, I don't know, like that, and graphing that, okay? And you got to know, what does that 3 do to this graph? What does that 1/2 do to the graph? Well, they do specific things to this graph. You remember from before, don't you, when we did stuff like y equals x squared, we called that the parent function, and then we messed around with it, didn't we? We moved it left and right, and we moved it up and down, didn't we? So just looking at this, you said, okay, the parent function is a parabola, it's a y equals x squared, but what does this do to that graph? Moved it to the right. Yeah, you're right. This 3 right here, though, according to this one, just wait a minute. He just read ahead, all right? So this right here is moves it to the right, and this moves it up. What's wrong with reading ahead? That's what you should be doing. Okay, why do you chastise him for that kind of thing? Okay, look, it's got an eraser tool, which my other program didn't have. Okay, which is awesome. Okay, that's pretty cool. All right, I just wish the